Hello. It's been a while since we last talked about the LED strip project. By my calculations, it's been at least 2 units of time since we last talked about it. And I think I can sum up what happened in the last few weeks in 3 phrases: refactoring, bug fixes, and scope creep. Roll the music. Welcome back to EEforEveryone. Today we're going to talk about the LED project that I've been trying so hard to not call Internet of Things. However, we've hit critical internetiness and I can't avoid it anymore. So it is now an IoT LED project. If you're my regular viewer, you may have noticed that this project is not moving with my usual velocity. And if you're not, then everything is under control. Don't even worry about it. While I don't need to make up excuses for why this project isn't moving as quickly as it should, I will anyways. When we left off with part 3, the project looked pretty similar to how it does now on the surface. But at the core of the project, the heart of the server code that's keeping this thing alive, it is very different. That core has been scaled to use a custom firmware that's flashed onto ESP8266 modules, which is much cheaper than the Arduino Megas that this architecture was originally using, not to mention it improves its performance a bit. This brings the cost down for each of those controllers on each LED strip down to like $6. That's basically free. And it also improves performance. On top of that, the server has been updated to now handle as many LED strips as the computer has RAM, which is a lot, considering we only need about 900 bytes to keep a 300 pixel LED strip running. Animation sequences with only one step are now handled gracefully instead of being ignored. And last but certainly not least, and by certainly not least, I mean the thing that I've been chasing around for 2 weeks, the server can handle LED strips dropping connections gracefully, regardless of when they drop. In the middle of a frame transmission, in between frames, after being idle for a long time, immediately after not acting a frame or just disappearing, it's all handled. There are so many edge cases that can cause a strip to momentarily or completely abandon the socket. And handling those situations gracefully while allowing the other strips to continue operating as normal is a pain. In that rambling, I said the word gracefully a few times, and what I mean by that is that it doesn't crash the entire server running in Java, which is altogether a marked improvement. When an animation is requested, the server scales that animation for each strip to the length of each LED strip, timing them based on the performance of the system, and then streams them to an arbitrary number of clients, managing the frame-by-frame synchronization of the different clients. Before I get ahead of myself on how this is happening and everything going on under the hood, which admittedly might strain the attention span of the average person, myself included, I want to show off some glam footage of this system, doing what it does best, looking better than a brand new coat of paint. Woo! Where do we go from here? First, in order to handle large numbers of LED strips, eventually the TCP transmission will need to be multi-threaded. That's not the case now. Also, I want to implement zoning and persistence. What I mean by that is a strip can subscribe to the global channel, where any animation from any web interface can be streamed to any number of strips distributed around the globe. If, for example, a person wanted their LED strips to turn off at night and be disabled from the global channel, so all of your friends, family, and any person you happen to brag about these awesome LED strips to can't turn on like a rave in the middle of the night and wake you up, for example. They could have their LED strips tied to a channel ID, where each LED strip is identified by a unique identification code and then subscribes to that unique channel ID. This unique channel ID can then be disabled through a separate secure port not exposed to the wider internet that would allow anyone to submit an animation to that channel, or you could lock down the channel to only allow yourself to submit it through that secure port, but it won't actually display on the strips unless you've got your internet light switch turned on. This buys us something incredibly useful besides saving power and keeping the LED strips off when I want to be asleep. The ability to identify a particular client throughout network interruptions, power loss, being disconnected for a while, move to a different network, plug back in, all of that, tracking that unique ID regardless of where it's connecting from and how long it's been connected with its particular channel ID and subscription status and other indicators saved throughout those disconnections. All of this would be tracked using that unique identification code assigned by the server. With these unique IDs and subscription status and allowing to zone LED strips based on a unique identifier assigned by the server, this would allow us to stream animations across all of the strips as if they were one big strip, instead of being locked into treating them all as individual clients and treating them the same, while scaling that massive animation stream to all those strips down to an arbitrary length, for example, a single client that wasn't behaving as a whole room, as a whole channel ID. That's pretty cool, right? At least I think so. I've prepared some diagrams to explain what's going on a little better to you, so you can be as excited about this as I am. The core of the functionality of the system is the EEforEveryone Java server. Then, of course, the web clients can connect via the internet using HTTP traffic and JavaScript to, connect to the server, the Tomcat server. And this Tomcat server is living on that EEforEveryone Java server. Now, of course, the Java TCP drivers, as we've been calling them in the GitHub repository, those are managing everything else. So the Tomcat server gets all the data that it needs from the user, from the web interface. It'll pull that down into some instructions that the TCP drivers can handle, and it'll pass that down through the server from the one Tomcat server processing area to the drivers area that I've been owning. Then, of course, that passes TCP through the internet to a number of LED strips. The number, of course, isn't defined by anything in principle. There just comes a point where the server crashes and breaks down and can no longer function. That is the limit of how many LED strips can connect. Well, that, or whatever type class they're storing our array in, whenever that overflows or the index can't be returned anymore, that is the limit of how many LED strips can connect if the hardware does not bottleneck it. And then, of course, there's that line drawn where that's showing the line where the Tomcat server needs to pass data to the Java TCP drivers. So speaking of those drivers, the point of this is to get sweet animations to our established LED strips. That is the whole point of these driver classes. There are some side benefits to the way that we've put them together that makes them useful for arbitrary data transfer between a number of clients and this one server. And I intend to, in the future, not the future, the coming weeks, the almost right now, I intend to pull this to allow for more abstract data transfer between these clients, which are now being referred to as LED strips, and the sweet processing power of having a full computer driving your I/O on these microcontrollers. I don't mean directly, by all means. I mean through TCP with automatic retransmission, which is the power behind these TCP drivers, is that there's automatic retransmission built into both the client node and the server in Java. So if there's, for example, a network interruption, something breaks, something blows up, it just kind of fixes itself. It's amazing how well that works. You can rip the power cord out of a client, plug it back in, and, well, with some work, these drivers recover and allow that client to reconnect. But in order to get the sweet animations to the established LED strips, the first step in that is to make a new LED strip an established LED strip. So there's some code that acquires new clients, waits for their connection, initializes them, figures out how many LEDs are there, etc., etc. Whatever you want from the client before it gets shoved into the group of established known good clients, this is where that code lives. And then there's some other code that generates some animations. So no longer we're talking about sweet animations in abstract, we're talking about frame by frame animation generation and then animation playback, which ends up, all right, so the animation generation sets up a for loop, basically, to use some code to generate animations based on some colors that are passed to it. And then those objects set up for playback are handed to the playback side of things, which then take that data and push it out to the LED strips using some parallel transmission and timeout management that, at any rate. So then there's one server thread around that client acquisition, initialization, and verification, and then a second thread around that animation playback and generation. Then there's thread n+2 managing the transmission and timeout, so that when one strip is timing out, we can allow the rest of the threads to continue and play the animation and just kind of put that thread that's timing out in an idle state so that animation generator, or the animation playback, will step through in lockstep with the other strips, and whenever it comes back, it'll snap to the same location as the rest of the strips, as if it were connected the whole time. And then there's that key transition from acquired LED strip into the array of generation and playback, and I put that arrow there for a reason, because during animation playback, that new LED strip will not begin receiving frames until the next time the animations are generated. The next time the animation's generated, basically it'll add a generator for that new strip, and then because there's a generator for it, it'll get some frames sent to it. Without the generator, the playback doesn't work. So every loop iteration, every time it plays through the animation sequence from start to finish, that is when the new LED strips will begin receiving frames. So that's a lot. Coming back to the system architecture, we've got the internet, the web interface, the Tomcat server, the drivers, and then that pushes out frames via TCP over the wide area network to our many LED strips. And then there's this new idea that I had that's really been slowing down the progress, but it's so cool. And it's this diagnostic port controller. And what this diagnostic port controller would allow me to do is go into like a debug mode where we'd stop streaming frames and basically just make an LED strip flash in a certain zone. So I'd be like, all right, I want to diagnose zone 1, and zone 1 would start to flash. Strip 1 and zone 1 would start to flash. It's like, all right, there's strip 1, and then, all right, what's strip 2? Strip 2 would start to flash. Strip 3, index through all your strips, and then it's like, all right, I want to order these strips, reorder these. So strip 1, this unique ID is now strip 1, this one's now strip 3, this one's now strip 2. All right, I've reordered my strips around my house, and now this is where I can coordinate a sweep, no longer to go from one end to the other end of a strip, but to go around a room through the many strips and then end up at one place. And that is the key difference. Right now that is the key difference between strips that are synchronized and strips that are so synchronized, there's no discernible difference between one strip running on one Arduino and 50 strips running on 50 Arduinos, because this master Java server can decide which strips should be considered one and which strips should be considered many, and control them simultaneously, scaling the animations as it should, grouping animation generators and splitting them back apart and streaming them to whatever it needs to, managing retransmission and dropout and all that, such that if strip 1 and 3 still exist and strip 2 has disappeared into the ether, strip 1 and 3 will still work fine and strip 2 will wait for reconnection. We'll get there. Give me a couple more weeks. I think, all things considered, we've made some good progress. We've gone a long way, but there's more to do to take this from really cool to distributable, scalable, supportable. And, well, for no particular reason, that's what I want to do. So, smash that like button if you think this idea is cool. Smash that like button if you want to get this running on your network, on a computer in your closet. One more thing, actually, before we call this quit. I want to say something about this server. The word server is very scary. The word server makes people think of, well, nightmares and downtime and complicated setup. This server is a Windows computer. It could be a Raspberry Pi. It could be a Linux computer. The only requirement for this Java server is being able to run Tomcat, as far as I know, and being able to run Java executable. So if it can run Java and it can run a Tomcat server, you're golden. That can be your server. It could be your normal Windows computer sitting by your desk. It could be your laptop. It could be a virtual machine running on a server. It doesn't matter. It's just a computer. It doesn't need to be more complicated than it is. It could be a Raspberry Pi, like I said. So when you're looking to set this up at home, in your network, with your LED strips and your ESP8266 modules, just remember, you only need as much RAM and processing power as your LED strips will require. As much as your sensors you want to add onto this network require. It doesn't need to be more complicated than it is. Don't let the word server scare you. It's not as hard as it looks. Having a server run on a computer 24/7 that I've written myself that manages multiple low-level microcontrollers has opened up a huge window of opportunity. It would be utterly trivial to add things like AC connected outlets, temperature monitoring throughout a home, cameras, you name it. Anything that a microcontroller can control is now able to be monitored and controlled by this computer running in my closet, linking multiple otherwise unconnected systems to this single point of truth. Even if all of those are operating autonomously and sending their status back to this main server, that's incredible. And then there's the web interface that ties it all together and really just makes it easy to use. Once you've got the web interface, once you've got the ports that the LEDs are connecting to, you just need to do some port forwarding in a router or some reverse proxy for the web interface to prevent intrusions. That's a whole nother thing. Not going to get into that now. But all you have to do is regular internet things to scale this from my house to everyone's house. And that is the cool thing about this project. The cool thing about this project is that it's not me working in a vacuum doing something here. It's me doing something here, running on a server 24/7, and then anyone in the world can connect an LED strip to my network. Anyone in the world can access the web interface and change what animation's playing. This could be in a car, connected via a phone tethered to the cell network, running off the battery in the middle of nowhere, and it could connect back to this server and get streamed animation data synchronized to my apartment. Cool, right? This project is a gateway drug to an unbelievably connected, easy to interface with Internet of Things platform. The big thing that I'm seeing lacking in all these Internet of how do I say it? That my biggest gripe with the Internet of crap systems is that they're all trying to be independently secure. They're all locking down their proprietary ecosystem with all this encryption and security, and they don't put enough time into the security, so it sucks anyway. So it's inconvenient for me to try to interface with and hack, and it's easy for a hacker to get into. That's the worst of both worlds. I would rather have a system be easy to interface with and blatantly unencrypted, so that the users know that you need to use regular security systems to lock down those nodes and prevent them from being exposed to the WAN, limiting the scope of the nodes so that you can't compromise a critical system by getting in, thinking about security rather than trying to lock everything down poorly, allowing it to be open, easy to interface with, and making the router the firewall for the system, which is always what everyone does anyways. Now, it's a bit of a rant, but the point is, I know this system isn't secure. I know that you could write a script at home and you could submit a garbage animation sequence to my server. I know that that could make the LEDs look a little weird. But what's the impact? There's no impact. That doesn't matter. You could compromise a strip and try to spoof being me and then try to stream animation data to my LED strips. But what would it matter? They would display, reboot, and fix it. Wouldn't really matter. You can't execute arbitrary code on these little nodes and then compromise my whole network and turn it into a botnet. That's just not how that works. There is a finite set of code that this can execute, and its options are if received packet, display to LED strips, or ignore. That doesn't leave a hacker much leeway. So, I don't know, maybe someday we'll find a way to incorporate security, but generally speaking, the way that security will be implemented would be this server lives on my network, and its connections to other things can be encrypted through libraries easily accessible when you're developing in Java. And that's a big part of the point of why this is being developed in Java. It's for that web interface, for the libraries, for the higher level functionality that would be incredibly difficult to implement on an Arduino. So, we're going to keep pushing forward. If you think that this project is cool, this video is great, and you want to see more like this, let me know by hitting the like button on this video, subscribing to the channel, and leaving a comment letting us know what you enjoyed. Most of all, I hope that you learned something great today, and I hope to see you again soon. Bye!